Hello everyone. In the previous videos we have seen that a vector can be resolved in 2 dimensions as well as in 3 dimensions. When we consider the resolution of vector in 2 dimensions, like suppose we consider vector r, which has to be resolved along x-axis and y-axis, so it can be represented in terms of x I cap plus y j cap, where I cap and j cap are the unit vectors along x-axis and y-axis. Similarly, if a vector r can be has to be resolved in 3 dimensions, that is along x-axis, y-axis and z-axis, then we represent the vector r as x I cap plus y j cap plus z k cap. That is in the 3 dimensions where the unit vectors are I cap, j cap and k cap respectively for x-axis, y-axis and z-axis. Now, here in this video what we are going to discuss is how the vectors are multiplied. Now, the multiplication of vectors are a totally different concept. When we multiply vectors, then it is not done in the way in which in algebra we multiply the numerical values. There are 2 different ways in which we can multiply a vector. One is the dot product, or it is also known as scalar product, and another is the vector product, which is also known as cross product. So we will be discussing the vector or the cross product in the next videos which will follow. But in this video we are going to discuss the dot product of 2 vectors, that is the scalar product of 2 vectors. So let us see how it is done. Scalar product or dot product. Now first of all we will see the definition here. Scalar or dot product of 2 vectors, vector A and vector B, is defined as the product of the magnitude of vector A and B and cosine of the angle theta between them. That means if the 2 vectors A and B are given, then their dot product is the product of the magnitudes, that is A, B, into sine of the angle between vector A and vector B. So this is the way in which it is represented. Vector A dot vector B, product of the magnitude of vector A and vector B and cos of the angle between them. It is also written as AB cos theta. You can see here in this case we are writing the magnitude only and it doesn't have any direction. Okay. So if it doesn't have any direction, so that's why it is called scalar product, because the 2 vector quantities, when they are multiplied as dot product between them, then the result is a scalar quantity, which is AB cos theta. Let us see the diagram also. 2 vectors, vector A and vector B, are given, and you can see the angle between them is theta. So vector A dot vector B is given by AB cos theta, where A is the magnitude of vector A, B is the magnitude of vector B, and cos theta is the angle between vector A and vector B. So this whole quantity AB cos theta is a scalar quantity. So we write vector A dot vector B is equal to AB cos theta. I hope this is very clear to you. Now see, when we consider this vector A and vector B, so we can take the component of vector B along vector A, which is B cos theta. As you can see here, we can drop a perpendicular here, so it is B cos theta is the component of vector B along vector A. So when we write vector A dot vector B, it is AB cos theta, that is A into B cos theta, and B cos theta is OR here, which is the component of vector B along the vector A. So we can finally write A into B cos theta, which is A into magnitude of the component of vector B along vector A, along the direction of vector A, which is B cos theta. I hope this is clear to you. Now there is another way also of writing it. Suppose we take the component of vector A along vector B. Along with the angle, I have already told you, when we take the component along the angle, so this angle, this component will be in terms of cos theta. So we write here A cos theta, which is the component of vector A along vector B. So again, if we write vector A dot vector B, which is AB cos theta, so B we can write at the beginning into A cos theta, and which A cos theta is the value which is the length of OS, and it is the magnitude of vector A, component of vector A in the direction of vector B. So what we have seen now is vector A dot vector B can be written as AB cos theta, which is A into magnitude of component of vector B in the direction of vector A, or it can also be written as B into magnitude of component of vector A in the direction of vector B. So I hope this is very clear to you. Now let us discuss some of the examples, actual examples which we will consider in our physical situation. So let us see those examples. The first example is when we derive a relation for force. Okay. The relation for work done, sorry, not force, work done. Suppose work is done on a body because a force F acts on the body and it displaces the body by S. So force and displacement both are vector quantities. So the dot product of force and displacement gives us the work done. So I hope this is very clear to you. This formula you are going to study in the next part of the syllabus, in the later part of the syllabus, where we will be going to discuss this in a very detailed manner. But for the time being, since we are showing only the example of the dot product, so force dot displacement, they are vector quantities, we get work, and work is a scalar quantity. You need to understand that the dot product of the two vectors, the answer will be a quantity which is scalar in nature. Okay. Now next example is power. Power associated with a body is the force applied on the body and the dot product of the force applied on the body and the velocity attained by the body. So P is written as F dot V. Again you can see here the dot product of two vectors vector quantity, force and velocity. The result power is a scalar quantity. It is not a vector quantity. Another example we can take, magnetic flux. This topic is also included in class 12, so you will study there in class 12, and P is equal to F dot V. This is also included in your class 11 syllabus, but in the later part. So you will understand all these in a very detailed manner, but here we are only taking the example of dot product. That's why I have considered those particular formulas. Okay? Now magnetic flux. You must have studied magnetic lines of force in class 10th. Now, magnetic flux is a physical quantity which gives the measure of the number of magnetic lines of force which passes perpendicularly through a surface. Okay. So, the detailed way you will study in class 12. So, it is also this magnetic flux which is represented by phi. It is also given by the dot product of the magnetic field and the area, B dot A. Okay. So, I think this is also clear to you. See, these are only the three examples of dot product. Now, we will also discuss here how the scalar product can be represented in terms of rectangular components. Okay, like rectangular components, suppose we have two vectors, vector A and vector B, which are given by AX I cap plus AY j cap plus AZ k cap, and vector B is represented as BX I cap, BY j cap and BZ k cap. AX, AY and AZ are the components of vector A along x-axis, y-axis and z-axis respectively. And vector I cap, j cap and k cap are the unit vectors along x-axis, y-axis and z-axis. Similarly, in vector B, BX, BY and BZ are the components of vector B along x-axis, y-axis and z-axis respectively. So, we have to take the vector product. The dot product of the two vectors, that is vector A and vector B. It is also known as the scalar product. So when we take the scalar product or the dot product of the two vectors, that is vector A dot vector B. So let us see here how it is done. Sorry. Vector A and vector B dot product. So we have expanded vector A and we have expanded vector B and we have put a dot here so to represent the dot product. So that means all the three terms of vector A will be multiplied one by one with all the terms of vector B. So we have written here AX I cap dot BX I cap plus BY J cap plus BZ K cap plus the second term we are taking AY J cap dot BX I cap plus BY J cap plus BZ K cap, and the last term AZ K cap into BX I cap plus BY J cap plus BZ K cap. So these are the dot products. We have just represented it. Now let us see how we are going to deal with it. What we do is, in the first case, AX I cap will be multiplied one by one with BX I cap, BY J cap and BZ K cap. So that's what we have written here. So AX and BX, they are the scalar quantity. They are the numerical values, say 2, 3, 5, 6, all the numerical values. So they will be directly multiplied. But the dot product will be in between the vectors, which is unit vector I cap dot I cap, first term. Then secondly AX BY, then I cap dot J cap, which we have written here. Then the term which includes I cap dot K cap. Then we come to the next one where J cap dot I cap, then J cap dot J cap and J cap dot K cap, and finally the last term where we come K cap dot I cap, then K cap dot J cap and K cap dot K cap. So these are the terms which we are having. Now you need to understand one very important thing here. When we take the dot product, vector A dot vector B is given by AB cos theta, where A is the magnitude of vector A, B is the magnitude of vector B, and cos theta is the angle between them. Now when we take vector I cap dot I cap, then I, the unit vector, has a magnitude 1. This is also I has a magnitude 1, and the angle between them is 0 degrees. So 1 into 1, that is vector A dot vector B, we write AB cos theta. So here it will be 1 into cos 0. Cos 0 is also 1. So I dot I is 1. But when we take I dot J, the angle between them is 90 degrees. So cos 90 will be 0. So the whole term here becomes 0. I dot K, again it becomes 0 because the angle is 90 degrees. So wherever you find the similar unit vectors like J dot J, so this is 1. Otherwise J dot I and J dot K will give you 0. Same here in the last term, K dot K will be 1. So we'll be left out with only 3 terms, AX, BX, then here it is AY, BY, and finally AZ, BZ. Okay. So the final result that we are getting is AX, BX, AY, BY and AZ, BZ. So when two vectors are given, vector A and vector B, in terms of the rectangular component, then their rectangular component which belongs to I cap will be multiplied, then that belongs to J cap will be multiplied, and that belongs to K cap will be multiplied, and we will get the value of vector A dot vector B. So we have explained two different ways. Vector A dot vector B, if the angle is given and the magnitude is known, so we can write vector A dot vector B as AB cos theta. And in terms of rectangular component, we can write as AX BX plus AY BY plus AZ BZ. So these are the two different ways in which we can represent vector A dot vector B. Now finally, this representation here which we got here, the scalar product of two vectors is equal to the product of the magnitude of one vector and the magnitude of the component of the other vector in the direction of the first vector. That is, in the I cap direction, along x-axis we are multiplying AX BX plus similarly along y-axis AY BY and AZ BZ. So I hope this is very clear to you. Any doubt you can post me the doubt. Thank you.